Hello everyone. In this video we will continue to talk about home buying. There is a formula for computing monthly payments on a mortgage. So in the last video we talked about using a table to do this, but the table only reflected some of the possible interest rates and some of the terms for a mortgage. So this is a formula that you could use in any situation, and you can use whatever you would like for the term, the number of years. And you also have the freedom to choose the rate. So if we had something strange like 6.217 that was not in the table, then this formula is the way to go. So we're using R to stand for the regular monthly payment. P is still for principal, little r is for rate, N is the number of payments per year, and T is the number of years. For entering this on your calculator, you should put in two implied parentheses, which are not written in the formula. You need one around the denominator, and that's because we have two terms here. We have this one, the first term, then the minus sign shows a separation. There's going to be a second term following that, and then this whole parentheses raised to an exponent is the second term. So putting the parentheses there tells the calculator to divide by everything in the denominator, not just one term or the other. The second place you need parentheses is around your exponent, around the negative nt. Alright, so when you do your exponent, or maybe it's like y to the x, alright, then put parentheses around that exponent. Alright, so let's try an example. Let's use this formula to find the monthly payment for a young singer who, after a one-hit single, decided that she needed a $2.2 million mansion. She put $500,000 down and financed $1.7 million at 6% for 30 years. Find her monthly payment. Okay, so substituting into the formula, we have R is the monthly payment. They give us the principal here because we know what she put down and we know what's left. So the $1.7 million is the principal. Alright, and I think I'll write this out the way you would do this in a calculator. So next you would do parentheses, and then you want the rate as a decimal, so 0.06 divided by, and you can use you'd see a division symbol on your calculator. Alright, so divided by 12, close parentheses, then division sign, we're moving into the denominator. Put a parentheses around the whole denominator, then 1 minus, parentheses, 1 plus, then the rate, 0.06, divided by 12, close parentheses, and then whatever your exponent key is, either a caret or y to the x or a to the b, okay. Then parentheses for the exponent, then negative 12 times 30. Okay, so this is a 30-year mortgage, right? And the 12, notice this is a monthly payment, so N is 12, okay, in all of these cases. All right, it's a 30-year mortgage. And then I think the only thing we need now is just an extra parentheses to close the denominator. Okay. So that's how you would enter that in your calculator, and that gives you a monthly payment, a ridiculous monthly payment, $10,192.36. Okay, a second example. Use the same formula to find the monthly payment on the one-hit wonder pop star's second house. So apparently she didn't make it after that first CD. It's a $120,000 mortgage at 5.2% for 15 years. Okay, so this $120,000 mortgage, that is the principal of the mortgage. So we don't actually know the cost of the home or what she put down, but that's going to be the P in the formula. All right, so we have, using the formula, R equals P, which is 120,000, all right, times the rate, over 12 because it's still a monthly payment. Then in the denominator we would have 1 minus 1 plus 0.052 divided by 12. And then the exponent would be negative 12 times 15. Okay, so entering that in your calculator would look like this. 0.052 divided by 12, close parentheses, division, parentheses for the denominator, 1 minus 1 plus 0.052 divided by 12, close parentheses, exponent key, parentheses, negative 12 times 15, close that parentheses, and close one more for the denominator. And that should give you a monthly payment. Here's hoping you get this number, $961.5, right, or $961.50. So still expensive, but a bit more reasonable for a monthly payment on her second home. Okay, the other thing that I would like to talk about in this video is computing an amortization table. So after securing a mortgage, the lending institution will prepare one of these tables or schedules, and this shows you what part of the monthly payment is going towards the principal of the mortgage and what part is going towards the interest. Right. Now you may also be familiar with principal-only payments. All right, principal-only. So you're required to make, if you're making monthly payments, then the first one you make is required to be divided between the principal and the interest. You have to start paying down that interest. However, if you'd like to make extra payments, you can make a principal-only payment, and those would be in addition to the ones that you would see in this table. All right, so watch as we go through the example here, and you can see how much is going towards interest, and think about how that would be helpful if you made extra payments just towards the principal. So here's the process. We need to find the interest for the first month, and then what we're going to do is just take this monthly payment and subtract away the amount that goes towards interest, and that allows us to see the amount that goes towards the payment on the principal. All right, so we're just subtracting interest from monthly payment, recording the two different amounts in the table, and then in step 3, we want to subtract the payment on the principal to get the new balance of the loan. So in other words, if somebody started out with a $100,000 mortgage, and let's say that the first month, let's say that they made monthly payments of $500, and let's say that the first month $100 of that went to interest, then only $400 would be going towards principal. So then after the first month, this balance of the mortgage would be down to $100,000. Oops, sorry, $99,000 and $99,600. All right, so that only drops by $400 because $100 of that went towards interest, not towards paying off the principal. Right, and then we just keep repeating these same steps, but using this new balance instead of the original principal for the mortgage. All right, so let's try it out. Compute the first 2 months of an amortization schedule for the loan in example 4. All right, so if you look back at this example, we did this one previously. The principal of the mortgage was $139,920. It was a 5.5%, this is an annual rate mortgage, and then the monthly payment was $794.75. All right, so for payment number 1, the amount that goes towards interest, right, we need to use the formula that was given here, I equals PRT. So it's a simple interest formula where T is 1/12. Okay, since it's just 1 month out of the year. Okay, so we have the principal. Right, so I equals PRT, principal times rate, and then times time, which is 1/12. Right, and that gives $604 $41.30. So that's the monthly amount of interest. All right, that number goes here in the table. Okay, and then the payment on principal would just be whatever's left from the monthly payment that did not go towards interest. So take the $794.75, that's the monthly payment, subtract the amount that went towards interest, and then whatever's left is what goes towards the principal. And this month it's $153.45. Okay, so you can see why so much money goes towards interest and why these amounts are so high. It's because we've got this huge principal, and that results in a huge, even though the rate isn't too bad, 5.5%, it's still a large amount of money that needs to be paid each month on the interest, all right, just because the loan is so large. And that means that it's going to take a lot longer to pay this off because the amount you're paying each month, hardly any of it actually goes towards the principal of the mortgage. All right, now the balance of the loan, we need to take the principal and then subtract the payment on the principal. Right. So this is the first payment, so we have the original principal, then minus $153.45 tells you how much is left to pay off on this mortgage. Okay, and that gives, well, let's see. Okay, that's $139,766.55. Okay, and then for the second month, we're just going to repeat the same steps, but now we have this new balance of the loan as the principal. So we're using this number. Okay, and we're using the formula I equals PRT. All right, so same rate and same time period, it's going to be another 1/12. All right, so for this month, the interest is $640.60. Okay, now the payment on principal, now we're subtracting $794.75, the monthly payment, minus the new interest amount. Okay, and that gives a payment on principal of $154.15. Okay, and then subtracting to find the balance of the loan. All right, so we're keeping a running total here. So the previous balance from the previous month was $139,766.55. And now you're subtracting $154.15, that's the second month's payment on principal. And then the new balance is $139,612.40. All right, so as you go through these tables, and we could keep going here, we could do a third month, and we could just keep going for the entire length of the loan. But notice that none of the numbers you see will be the same. So your interest amount, this should always be decreasing because you're taking the same rate in the same time, but the principal is slowly lowering over time. And that means that the payment on principal will actually be going up because it's less each month goes to interest, more is going towards principal, and then the balance of the loan should be going down over time as well. So if you don't see those three things, then that's a clue that you need to back up and check something went wrong. All right, let's try one more example. Make an amortization schedule for the first 3 months of the loan and try this one example, number 4. So this mortgage had a principal of $195,075. It was a 5% mortgage, and the monthly payment was $1,287.50. Okay, so step 1, find the interest for the first month. Do principal times rate as a decimal times time, we're using 1/12. Okay, so that gives an interest amount of, let's see, 812 and 81 cents. Okay, then to find the payment on principal, take the monthly payment and subtract the interest amount. Whatever's left goes towards principal, and that's $474.69. And then finally, the balance of the loan would be the previous principal, $195,075, minus the amount that got paid towards the principal. And the new balance for the mortgage is $194,631. Okay, for the next month, repeat those steps. We have a new principal. Okay, the new balance of the mortgage. Oops. All right, times 0.05 times 1/12, or you could just divide by 12. All right, and that gives an amount of interest that's $810.83. All right, then the payment on principal, subtract $1287.50, the monthly payment, minus $810.83, and the amount that goes to principal is $476.67. All right, and then the new balance of the loan, take the previous balance, this number, $194,631, subtract $476.67, and then the new balance of the loan will be $194,644.99. Okay, and then one more time. To find the interest for the third month, we're going to multiply the previous month's balance. Okay, 194,644.99 times 0.05 times 1/12, and that gives 808.85. All right, subtract that number from $1287.50, and the amount that goes to principal is $478.65. And then the balance, the new balance, take the previous month's balance, subtract the payment on principal, and you get $193,644. Ooh, looks like I've got an, I think I jumped down a row here. Okay, let me back up. Different number here. Let's see. Okay, this number, when you subtract, should be 194,123.64. Okay, I'm reading this from the textbook. I skipped down a line in that table. Okay, so then here, this should be a different number, but I think you should still get the same answer for interest and payment on principal. Okay, so now we're multiplying 194,123.64. Okay, then that gives you the interest of $808.85, and then that subtracted from the monthly payment is $478.65, and then the new balance of the loan, this should be $193,644.99. Okay, there we go. All right, so again, you're seeing the interest slowly decrease over time, the payment on principal is increasing, and then the balance of the loan is decreasing.